Okay, so for the first one here, okay, we've got potassium reacting with water. Water is written as HOH. Is that a big deal? No. Okay, what kind of reaction is it? Single replacement. We have an element reacting with a ionic compound. All right, so that means then that our products are going to be that potassium is going to replace the metal, which is hydrogen. So potassium is going to end up with hydroxide, and hydrogen is going to end up by itself. Okay, single replacement reactions have the most to remember. What do I need to do here? I already did it. Just do it subconsciously. Yeah, I put a 2 on the hydrogen, special element. Okay, what's the other thing I have to do? Drop and swap. It's already done. It's 1 and 1. Okay, for this particular compound, potassium is a +1, hydroxide is a -1, so that one works out the way it is. Okay, now I have to balance. Okay, and sometimes people get confused when they see HOH, okay, and then they see a 2 over here. They go back and they're like, oh, well, there's already 2 hydrogens, so it's balanced. But they forget that this hydrogen's already accounted for over here. Okay, so it's not balanced yet. I need to put a 2 here because I have 2 hydrogens over here. Okay, now when I do that, it gives me 2 hydroxides, so I need to put a 2 in front of this. Okay, and that's going to give me 2 potassiums, so I need a 2 in front of this. So everything except for the hydrogen gets a 2 in front of it. Okay, the hydrogen doesn't need the 2 in front because it's got a 2 behind. All right, so just that's one of those things to kind of watch for when you see water written as HOH. When you're balancing, watch for that. Okay. Number 2, I think we may have talked about this yesterday, okay, but it's still something that we need to remember, okay, and that is if I have an ionic compound containing a multivalent metal, okay, like copper or iron or something like that, I need to determine its charge on the reactant side. That'll be its charge on the product side as well. Okay, so for this one here, okay, I know that sulfur's always a -2, and there are so that means I'm going to get 2 positive charges out of 2 copper ions. So each copper has a charge of 1. Okay, I need to get 2 positives from 2 atoms. That means each atom has a charge of +1. Okay, so this is copper 1 sulfate or sulfide, sorry. Okay, now we got a double replacement reaction. Okay, so we're going to swap the metals. So copper is going to end up with hydroxide, and sodium is going to end up with sulfide. Okay, so going back to dropping and swapping, I determined on the other side this is copper 1. Okay, so when I drop and swap, I've got a +1 and a -1, so that compound is okay the way it's written, doesn't need any brackets. This one's a +1, this is a -2. So I'm going to need to do that for my drop and swap. Okay, so that was the little trick on that one is you have to determine the charge on the reactant side first so you know what it will be when you drop and swap on the product side. All right, now I've got to balance this whole thing. I can start with copper or sodium. It won't make any difference which one I start with. Put a 2 here to balance my copper, which gives me 2 hydroxides. So I got to go back over here to balance my hydroxides. That 2 balances my sodiums, and I've got 1 sulfur and 1 sulfur, so now the reaction is balanced. Okay. Questions on number 2? Okay. Number 3, I think we talked about this one yesterday, but I wanted to review it as well. Is iron a multivalent metal? It's got more than 1 possible charge. In this reaction, there's no way for me to determine what that charge is, because on the reactant side, it's an element. Elements don't have charges, okay? Metals will have charges when they get into an ionic compound, same as nonmetals, but when they're by themselves, they have the same number of protons as they have electrons, and they're neutral. So we don't know if this is iron 2 or iron 3, and there's no way to determine it. So, how do I figure it out? Right, I use the first one on my periodic table. Okay, the most common charge is always listed first, and for iron, that's 3, right? Okay, so this is a synthesis reaction. Iron is going to end up with oxygen. Oxygen's always a -2. I have to go with the most common form of iron, which is +3. Okay, so we're going to have Fe2O3. Okay, that's a trick that comes up often, so you need to be on the lookout for it. I think we've talked about the trick with this one before, but I just wanted to review it. Okay, I've got a molecular compound that's going to decompose because it's my only reactant. So it's going to break down into its two elements. Okay, what do I need to watch for here? Special elements. Okay, decomposition reactions and single replacement reactions very often produce special elements. Okay, nitrogen's always a 2, phosphorus is always a 4. Okay, the mistake I see people make is they carry the numbers over from the other side. They know it's special, but they think it's this number. No, it's the number on your periodic table. Okay. All right, so when I do that, now I've got to go back and balance. So a 4 here will balance my phosphorus. That gives me 12 nitrogens. A 6 there gives me 12 nitrogens. And now I'm balanced again. Okay, questions on number 4? And then for question number 5, I think this is just the multivalent metal thing again, okay, because manganese just has a weird charge. No, it has more than one. It can be a 6 or a 7, right? No, 2 or a 3.
2 or 4.
2 or 4. There's like 5 charges listed on my periodic table up here. Okay, all right. So on this one here, okay, again, I've got to figure out what manganese is on the reactant side before I do anything else. Okay, so nitrogen's always a -2, and there are 4 nitrogens for a total of 8 negative charges. That means I've got to get 8 positive charges out. Oops, that's wrong. No, that's right. Nitrogen's 3. That's coffee. Okay. -3. There's 12 negative charges over here. Okay, that means I've got to get 12 positive charges from 3 manganese. So this is the manganese with the 4+ charge. Everybody okay with that? All right, so now that I know that, now I can start my double replacement reaction where I will switch the partners on the metals. So calcium is going to end up with nitrogen. Manganese is going to end up with fluorine. Okay, so I just made 2 new ionic compounds. What do I have to do? Drop and swap. Okay, nothing special about this one. Calcium's always a 2+, nitrogen's always a 3-, Ca3 and 2, so that one's good there. Okay, we did all this work to figure out that manganese is a +4, okay, on the reactant side, so it'll have the same charge on the product side. Fluorine's always a -1, so we're going to have MnF4. All right, so now we got to look at balancing this. Fluorine and nitrogen are both 4s. Here's the other little trick. In terms of balancing, if you have 2 things starting with the same number and you're not sure which one to start with the one with the biggest charge. Okay? It'll have more of an effect on the balancing than the smaller charge. So which has a bigger charge, nitrogen or fluorine? Nitrogen's a -3 versus a -1. Okay, so I'm going to start with it. There's 4 nitrogen over here. Now there are 4 nitrogen over here. That gives me 6 calcium, so I got to go back over here and make sure I've got 6 calcium. That gives me 12 fluorine. So I got to go back over here and make sure I have 12 fluorine, which gives me 3 manganese, which I have over here, so I know I've done it right. Okay. All right, questions on that one? So there's little things that come up. The skeleton is always the same. I got to determine the reaction type. I've got to use that pattern to figure out who goes with who, look for special elements, drop and swap, balance the reaction. All of that is always the same. But there's these little things that come up once in a while, okay, that we always have to be on the lookout for. Okay? That's what I'm trying to do with the reactions I'm giving you today, is show you some of those little things that come up. All right, I want you guys to try 6 through 10 there. Okay, so for number 6, I've got lithium bromide, an ionic compound, and it's reacting with phosphorus. Okay, so again, we have a single replacement reaction that's going on. Okay, phosphorus is our nonmetal, so it has, or is a nonmetal, so it has to replace the nonmetal part of lithium bromide, which would be bromide. Okay, so that means that lithium's new partner is going to be phosphorus, and bromine is going to end up by itself. Okay, single replacement reaction has the most to do with the products. Do I have any special elements? Okay, bromine is special, so it needs a 2. And I've got to drop and swap my ionic compound, -3 + 1, so Li3. P, okay, and then I need to balance, starting with phosphorus because it's the biggest number. All right, so a 4 there gives me 12 lithium, so I got to put a 12 here. That gives me 12 bromine and a 6 there. Okay. Everybody all right with that one? Yeah. Okay. All right, for number 7 here, what kind of reaction is that? Combustion. What are the products of a combustion reaction? Carbon dioxide and water. Okay, that's just one we got to memorize. If you see CHO on the reactant side, okay, CH plus O, it's a combustion reaction. Okay. All right, so those are our products. There's not a matter of really predicting that. That's just memorizing. Okay, now I've got to balance it. Do I need both rules for this one? I do not, because 9 is an odd number. All right, so I'm going to put a 9 in front of carbon. Okay, and then I'm going to balance hydrogen next because it's going to be in alphabetical order. Okay, there's 20 there. Now there are 20 here. Okay, 10 oxygens here, plus another 18 is 28. 14 times 2 is 28. Okay. All right. For number 8. So I've got cesium and I've got sulfur. Okay, now I didn't play the same trick on this one that I played on you in the quiz. Okay, I put it metal first, non-metal second, but again, that's something we need to watch out for because you can write the reactants in any order you want. Okay, so we got a synthesis reaction where a metal is going to go together with a non-metal to form an ionic compound. Okay, what do I need to do with that ionic compound? Drop and swap. Okay, so cesium is a +1, sulfur is a -2, so I'm going to have CS2S, okay, and then I'm going to need to balance starting with 8. Okay, so I got 8 sulfurs on both sides and 16 cesiums on both sides. Okay, for number 9, what kind of reaction am I looking at on number 9? Double replacement, both ionic compounds. Okay, do I have any special metals there, like multivalent metals, that I should check on? No. Okay, rubidium doesn't have more than 1 charge, neither does zinc. Okay, so I don't have to worry about any of that stuff. Okay, so just a standard double replacement reaction. There's actually nothing special about this one. Okay, so we're just gonna swap the metals. So zinc is gonna end up with chlorine, okay, and rubidium, okay, is going to end up with oxygen. Okay, so I've just made 2 ionic compounds. What do I have to do with both? Drop and swap. Okay, -1 +2, so I'm going to have a 2 on the chlorine. Okay, rubidium's a +1, oxygen's a -2, so I'm going to have a 2 there. Okay, so now I've got to balance the whole thing. I can start with rubidium or chlorine. It won't matter because I'm only adding 1 number. 2 right there takes care of the whole reaction. Okay, last one. What kind of reaction is that? Combustion. Okay, we got CH plus O. Doesn't matter what the numbers are. CH plus O2. Okay, and you've got a combustion reaction. What are always the products? CO2 and water. Okay. So on this side here, okay, I've got an even number of carbons. So what do I need to start with? Right, 2. Okay, so 2 times 8 is 16. Right, so I'm going to need to put a 16 in front of the carbon dioxide. 2 times 18 is 36. 18 times 2 is 36. So my hydrogens are now balanced. Okay, and now I need to look at my oxygens. I've got 18 oxygens here in the water, okay, plus another 32 oxygens here in the carbon dioxide for a total of 50. 25 oxygens. That reaction there is the reaction that moves your car forwards, provided you don't have an electric vehicle. Okay, C8H18 is octane. Okay, if you've ever filled up your car, okay, that the amount of octane that is in your fuel is the difference between whether you have regular, mid-grade, or premium in your tank. Okay, regular is usually 87 octane, Okay, mid-grade is 89 and premium is 91. Okay, it's different amounts, so it burns hotter. So something that burns premium fuel burns a little hotter and generates a little more power. Don't just think you should put premium fuel in your car, however. Okay, your car needs to call for premium fuel. It affects the compression. Your car is built to burn premium or built to not burn premium. Okay, because people get this idea, well, if I just put premium in, it'll be faster. No, it won't. Okay, and it'll ping like crazy and it's not good for it. All right, questions on any of those? Okay. So, going forward here, like I said, tomorrow we're going to do something new, which is the mole equation, which allows us to take reactions and figure out how much of each material there is in terms of grams. Okay, this tells us there's like 16 carbon dioxide molecules. Okay, but if I had a whole tank of gas, I could use these numbers to figure out how many kilograms of carbon dioxide my car would produce in burning a tank of fuel. This is the same kind of calculations that people use when they're determining how many tons of carbon dioxide are put into the air every year by people driving back and forth to work. Okay, it's that reaction that allows them to do that. Okay, and we're going to learn how to do those kinds of calculations starting tomorrow. Okay, and then, like I said, on Monday, okay, I will give you the entire class period to work on your reactions assignment, which has 30 questions. Okay, those 30 questions start out with 10 questions where I have the reaction written out in formula form, and you would have to write it out in words, identify the type, just write it out in words and balance it. Okay, so that's what you have to do for those. Okay, so basically the first 10 are just a naming exercise, me testing whether you know how to do your naming stuff. The second set of 10, the full reactions are written out in word form, and you need to write them out in formula form, identify the type, and balance. Okay, so the stuff we were doing last week. And then the last 10 are like this. Okay, I give you the reactions, you predict the products and balance. So it's testing basically everything we've done up until now in chemistry. No.
Are we going to do, for the last one, they're going to be word ones as well?
No, they are all formula form. All right. Okay, so we were working on these ones yesterday. I think we got close to done those, did we not? So we just did a whole bunch where I gave you the reactions in formula form, but obviously those are a little bit easier than ones that are written out in words. Okay, so we've got 20 minutes left here. Okay, I would like to be able to get through, let's say, probably 5 of these, okay, if possible. Okay, so I want you guys to write out these ones. So you got to write out the reactants now in formula form, identify type, predict, and balance. Okay, so that's what we're looking at here. All right, so for question number 1, we've got lithium nitride reacts with water. Actually, 2 ways to do this one. Okay, so I got lithium nitride, that's an ionic compound that needs to be dropped and swapped. This is a -3, this is a +1, so I'm looking at Li3N. Okay, reacts with water, which in a double replacement reaction, I usually write like this. Okay, if you didn't write it that way, that's fine. There's still a correct answer for having written it as H2O. Okay, it just looks a little different, but in actuality, both would happen. Okay, so when I do this reaction here, okay, my metals are going to switch places. So lithium and hydrogen are going to swap partners. Okay, that means that lithium is going to end up with hydroxide, and hydrogen is going to end up with nitrogen. Since they're both ionic compounds, I need to drop and swap them both. That's a -3. This is a +1. Okay, and then this is a -1, and that's a +1. So that compound is fine the way it's written. Okay, now I need to balance the whole thing, probably starting with my lithium. Okay, put a 3 there. That gives me 3 hydroxides. I put a 3 there. I get my hydroxides and my hydrogens to balance. There's 1 nitrogen on both sides, so we're good. The other way you could have written that would be like this: Li3N plus H2O, and you would get Li with O. Okay, and it would actually be Li2O, okay, plus still H3N. Okay, and then we would have to, the balancing would be a bit different. Okay, so we've got 2 hydrogens and 3 over here, so a 2 and a 3, okay, giving us a total of 6 there, okay, and then I need to put a 3 here. That would give me 6 lithium. 2 there will fix my nitrogens, and then it would work out that way. So it looks a little different, but both would be okay. All right, questions on number 1? Okay. Question number 2, powdered zinc metal, which is just zinc. Okay, so that those chunks of metal that you had in the lab, somebody just powdered them, okay, which is pretty easy. Okay, so powdered zinc reacts with sulfur, and they actually told you it's S8. I wouldn't do that. These people are much nicer than me. I would just say sulfur and hope that you'd remember it's special and needs an 8 beside it. All right, when this happens, okay, I've got what kind of reaction going on? Synthesis, yeah, I've got 2 elements. They're going to react to form a compound. They're going to react to form an ionic compound where zinc will go first and sulfur will go second. And then since it's ionic, I need to drop and swap. They're both 2s, so that's good. It's good this way. Now I need to balance 8 and 8 to make that work. Any questions on number 2? So if you're not done number 5, okay, give number 5 a try. Okay, so this says bauxite ore. It's just kind of extraneous information. Aluminum oxide decomposes using electricity. Okay, so it's just that stuff. All right, I'll give you a few more minutes there to get those ones done. We'll talk about them and then we'll clean up. Okay, so for number 3, we've got aluminum oxide. Okay, which is an ionic compound. This is a -2, this is a +3, so we've got Al2O3. It's decomposed using electricity. So that's going to break down to aluminum and oxygen, which is special. Right? It's a big thing we got to remember for that one. Then we got a balance, starting with our biggest number. There's 3 oxygens over here and 2 over there. The lowest common multiple is 6. Okay, so now my oxygens are balanced, but putting that 2 there gave me 4 aluminum. Okay, and now it's balanced for that decomposition reaction. Okay, for propane, for number 4, okay, we got C3H8. It's reacting with oxygen. Those always produce carbon dioxide and water. 3 is an odd number, so I don't need to start with a 2. There's 3 carbons over here, 8 hydrogens, 8 hydrogens. 4 times 1 oxygen is 4, plus 6 more is 10. Okay, that's what that one should look like. And then lastly, sodium chloride solution, okay, reacts with lead 2 nitrate. Okay, so this is the lead with the 2+ charge. Okay, so there'll need to be 2 nitrates. Okay, so we got a double replacement reaction in which we're going to swap the metals. So sodium will end up with nitrate, lead will end up with chlorine. Okay, lead's a 2 on this side, so it's a 2 on this side as well. 2 plus, 1 minus when I drop and swap. Okay, and then I need to balance everything. So we'll start with a 2 here to balance the nitrates. That's 2 sodium. 2 here balances the sodium. 2 chlorines, 1 lead, 1 lead. We're good. Okay, so over the next few days, including the weekend, my suggestion to you is, first off, get your lab report done. It's due on Monday. And secondly, if this is something that's still giving you trouble, try some from the practice sheets in your digital workbook and check them against the keys I posted in Google Classroom earlier in the week. Okay, the only way to get good at this is to practice. Okay, it will take a little bit of time to practice before Monday when you do your assignment and submit your lab. Okay.
Do you timing do that in your class on them?
No, I never make anything due. I shouldn't say that. I do once in a while, but not this one. Okay, it won't be due for a few days, probably the end of the week. All right, if I get everybody to mask up, we'll come around and spray down desks.
say that again.
Oh, thank you.
Like in the question that you guys did about the diet, I thought that was only whatever. So like some cow. Why am I so bad? I just missed two.